Hi everyone, I hope you are doing good. Welcome back to another video. In this video, we are going to learn how search works inside of these specific apps. For example, how does search works inside of Swiggy? How does search feature works inside of x.com, or how does Wikipedia is able to search among so many documents, billion of documents. So how is it that these they are able to search so quickly, and let's say for Swiggy app, how it is able to return the food item, restaurant items or list items so quickly. So we are going to look all of these things into the detail, and I do want to point it out that this video is about Elasticsearch. We are going to understand how Elasticsearch works, because in most of the videos on YouTube, if you go to learn Elasticsearch, they will tell you about how the data is structured, how API works, and everything, but they won't actually clear your concepts. So that is what I'm going to do now. That once you are done with this video, you can go on and start any of the Elasticsearch video once that you have watched before and did not understand. Now you will understand them perfectly, and you will be able to understand why Elasticsearch exists and what purpose does it solve. Okay, so let's see what all things we are going to cover in this video. So first we are going to talk about search engines in general. Then we are going to talk a bit about Elasticsearch, Solr and OpenSearch. These are three big distributions. And then we are going to talk about Apache Lucene. Now Apache Lucene is the one that does all the heavy lifting and actually is the core of Elasticsearch, Solr and OpenSearch. That's why I have put all these three things inside of this, even though the majority of the use cases Elasticsearch is being used, but it's important to understand the Apache Lucene, which is powering the Elasticsearch, and this way you will understand a bit about Solr and OpenSearch as well. And so we are for Apache Lucene, we are first going to talk about what it is, how does it work, what problem does it solve. We are going to talk about what are documents, what are indexes, and what are inverted indexes. We are going to keep this video short. This is just of an introductory video. We are not going to go into a lot of detail and try to do each and everything. We are just going to understand from a high level perspective what is Apache Lucene and how does it gets implemented inside of Elasticsearch, and how we are able to use that inside of multiple different apps, multiple different things, where we are able to create a search engine for a specific subset of data in a specific ecosystem. And at last we are going to talk about how everything works together with Apache Lucene, which includes all of these things. Okay, so let's start. Okay, so search engines. What are search engines? Search engine is a software used to find things in a particular subset of data. Now there are a lot of different kinds of search engines. We know some of the very popular search engines, that is Google, we have Bing. Now these are custom search engines. These search engines have been created from scratch with the sole purpose of finding the information out on the web. So they perform a lot of operations where they crawl a lot of websites, they index it, they rank it into multiple stages. They have a lot of business rules based on which you are able to see that if Google is giving you better results, if Bing is giving you better results, or any other search engine for that matter is giving you better results. So these are optimized only for web. Okay, now we have other search engines as well. For example, Twitter has its own search engine, Swiggy has its own search engine, and then Wikipedia has its own search engine. Now by the general regards, these you cannot search about everything inside of Swiggy's search engine or Twitter search engine. Why? Because it is trained for a subset of data. It is limited to that. So let's categorize the search engines into two categories. One is custom search engine, one is managed search engine. So custom search engine, as I talked about, it is about the search engines, those which have been created from scratch. And then we have managed search engines. Now what are managed search engines? Managed search engines are basically that you do an implementation of the search engine, but actually searching part is being done by some other managed service. Okay, so let's look at some of the managed search. So as we talked about at the start, we have Elasticsearch, we have Apache Solr, and then we have OpenSearch. These are the three main players when it comes to open source and custom building search engines, which do not include building it from scratch. So these are the three big players. Now Elastic is a product of Elastic AI company. Apache Solr is open source alternative which has adopted the Lucene from the very beginning, I think back in 1990, and OpenSearch is also an open source implementation of the same thing. Okay, so let's see what it actually is. Okay, so Apache Lucene is actually the core of all these search engines. Basically, yeah, these are distributed. All of these are distributed, and Apache Lucene is not distributed. Why? Because Apache Lucene solves a very specific problem, that is, it solves finding documents, finding something from the documents which has a very large amount of data. Okay, so for example, you have millions of records, you have billions of records, and you want to find that specific text inside of it. Now, how do you know in which document that text exists? So that is solved by Apache Lucene. Now, what Elasticsearch, Solr, and OpenSearch have done is they have built a wrapper around Apache Lucene, which lets them use Apache Lucene in a distributed environment. So you can scale this horizontally, and you are able to have multiple shards and multiple instances of Apache Lucene, where it actually work as a independent managed service. Okay, so what is Elasticsearch? It is just a wrapper on top of Apache Lucene that allows you to find anything very fast and very quickly. Same is for Apache Solr, and same is for OpenSearch. Now Apache Solr is very big. It is used by Wikipedia. Apache Lucene direct implementation has been done by x.com. Okay, so as I said, Apache Lucene is heart of and core of all the above three major managed distributions of Apache Lucene. Now, what Apache Lucene actually is? Apache Lucene is a information retrieval library. Okay, so as I mentioned that you have millions of documents, millions of records of some data. Okay, it could be unstructured data, it could be structured data, doesn't matter. Now, out of all of those, now you want to search that specific text, you want to retrieve that information. So Apache Lucene is the library that actually helps you retrieve the information, and this library is implemented by all other distributions. And Apache Lucene is full featured text search. Okay, so what you are able to search is text. You can't put images into it and directly search for images, similar images or something like that. It is for text. The primary use case is text. Okay, so Lucene is by itself not a search engine. Okay, Lucene is just a library that fetches the information from a given subset of data. You have 10 million records. Okay, so what Lucene will do is, Lucene will just fetch that data. Just fetch that data and gives back to the client. It does nothing else. Okay, it is not a search engine. Search engine is an implementation of Apache Lucene, which lets you create a search engine is a product that is created by Apache Lucene. Okay, so Apache Lucene only gives you ability to find any text from any data. any data means the subset of data. We just talk about example again, you have records, you want to fetch any particular text. For that's where Lucene comes into play. Okay, now let's look at the example. We have a scripts of, let's say we have three documents. One is Redis replication script, one is Redis clustering script, and one is search engine script. Okay, now these are three documents which contains the entire blob of text that I'm speaking, and which has been transcribed and put it into a document. Now let's say that we search for Redis keyword. It will return, the Lucene will return us document 1 and document 2. Why? Because Redis is being used in both of these documents. We talked about Redis here. If we search for clustering, it will give us document 2 because that's where it stays. And if we search for Elasticsearch, then it will return us document 3. So what it does is, given any query request you give to Lucene, it will tell you where does that the query reside, where does that live. Okay, it finds you and retrieve the source. So what are its features? What does it actually propose apart from that? So first thing is it is very fast. So if you have a lot of data, you can brute force this, you can search for all the millions and billions of records, but the response time will be very slow. You don't want to wait for 10 minutes just to search anything on internet or on any app. So Apache Lucene gives this record in milliseconds, in a matter of milliseconds, because of how it is created. It's so fast. Then you get high quality results. So Apache Lucene has some algorithms inside of it that tokenizes and filters the data. Okay, so it's not like, let's say that for example, we are also talking about Redis in this document 3 as well. So ideally it should also give you document 3 in the result when we search for Redis, but that is not the case, because Redis replication, Redis clustering is the main use case here. It has a lot of algorithms. That is used in order to filter out the data so that we only get high quality results. Third is ranking. Now Apache Lucene also let us introduce facets. What are facets? Facets are basically a different criteria based on which we can filter the data. Now, or by filter the data, or we can rank the data. For example, generally when you go for any online shopping platform, let's say Amazon, or you go by Swiggy or Instamart, and you have to sort by, let's say, veg or non-veg option, or you want to sort the search results by, let's say, price from high to low, from low to high, or based on the rating. So this is also supported by Apache Lucene. It lets us implement these at very ease in order to filter all of the data. Then we have data normalization. So if the data is not normalized, then we all know that it is very difficult to work with that data. We also have to normalize and denormalize for relational databases. So Apache Lucene by itself normalizes all of the data. For example, if you give it the text in capital cases and small cases, then it can save everything in small cases, so that it is easier for it to index and able to fetch that data. Okay, then we have incremental indexing. We will come back to this. So but in a gist, it keeps indexing as more documents come in. So it doesn't stop to index, or it doesn't destroy the earlier index. There is no downtime. It just keeps on indexing. So for example, data comes here, the indexing process starts, then data comes, indexing process starts, data comes, indexing process starts. Fetch can happen anytime they want. It doesn't stop, indexing doesn't stop that fetches. So incremental indexing will come on to that at the end, but it is very important and very crucial thing that happens with Apache Lucene, so that it doesn't have a downtime, and it's a very useful feature. It gives you eventual consistency pretty good. Okay, so let's now, since we have learned about what Apache Lucene is, what are its features, let's understand a bit about it. So documents. Now document Apache Lucene works on these documents actually. Now documents is any kind of data. So Lucene way of storing that data is documents. Now Lucene actually structures and store data in the form of documents only. It is also the atomic and unit data. So you cannot break document down while storing into some different data structures. Now document itself is a data structure, which is how Lucene saves all of the data in its memory. So it could be anything. Let's say that we have a document and we have a JSON document as of now. So we have name, age and gender. Now these name, age and genders are fields. These are called as fields. So every document has a lot of different fields. It could have one field, it could have X number of fields, but every document has fields, and indexing is done based on these fields only, not on the document, but on these fields it is done. So let's say that I have 10 different documents. Okay, these are this is, let's say, metadata of user, and I have 10 such metadata with different names. So indexing happens on the field, so that when I search for Sarthak, it returns me this particular document. This document is returned. So this is how the document structure is, and it is, as I said, it is the unit data. You cannot break it down, and it is atomic. Okay. Document could be JSON, could be a text blob, or a YAML, whatever we prefer. Okay, so now let's look at indexes. What are indexes? What is indexing? Because this is the main selling point of Lucene. This is how everything relies on, and indexes are actually the heart of Apache Lucene. So as how Apache Lucene is the core of Elasticsearch, Apache Solr and OpenSearch, that is similarly indexing is the heart of Apache Lucene. So what are indexes? Index is a collection of documents on which the search is performed. Okay, so let's say that we have a index here, and Lucene is just a big infra. Okay, Lucene, and whenever the client comes, so they actually come on indexes to actually search all the values, and index is the one which retrieves the value and gives back to the client. So it is a collection of documents on which the search is performed. Okay, now if we don't have index, then we won't be able to search. Okay, so index is the primary thing that every Apache Lucene instance needs to have. If it does not has, then we won't be able to perform any kind of search operations on index. Okay, so let's see how index in general works. So we have data clients which actually puts the data. These are all the documents. Okay, currently we have 3 documents. Now these gets indexed into an index. This is through indexing that we talked about. This is through incremental indexing. We'll come back to this. Okay, and then once it has been indexed, then search clients create search queries which gives search terms. Search terms. The queries that is given by client include search terms, and these terms are being fetched from the index. So as we talked about here, right, this Sarthak, so Sarthak name is the field, but Sarthak is the term. This is the term, and when clients want something, they give this thing. Okay, and Yeah, so when they send a term, we fetch it from index and then we send it back to the client. And this is how the workflow is the expected workflow for Apache Lucene is architected. So let's look at the internals of this index as well. So uh, inside of an index, so index is this entire thing. Okay, this is index. What happens is कि we have a lot of documents. Okay, let's say that these are all the documents D1 to D8. Now what will happen inside of a index? There are multiple segments. So what a segment is also a small group of document. So let's say from T0 to T1 three documents came. So what Lucene will do is it will create a segment of it. Okay, we will understand what a segment is right after this, but currently just thinking this is a segment. So it indexes all the data for these three documents and keep it in a particular segment, which is segment 1. Now let's say from T1 to T3 these three documents come, it will go into another segment, and then from T3, let's say TX, these two documents come, these will go into another segment. Now what ensures that what decides what data to go in a particular segment, and what for what data should new segment should be created. Now this for this we have a few parameters. Lucene has few parameters. One is RAM of the system instance, basically. Second is time. These are the two main things. Okay, so what happens, let's say that at T1, sorry, T0, this document came. Okay, now this document came, it will get stored in RAM right now. Okay, this is the first step, it gets stored in RAM. Now we have, let's say the RAM will store the data till T10. Okay, this is the max limit that the RAM will keep the data. After that it will flush into a particular disk which will create segment 1. Now at T1 another document came, it will also go to the RAM. So now the RAM would have D1 and T2, and currently it's T1 only, and it can go till T10. So what will happen is कि when the D3 comes, it fills up the RAM. Okay, no space is left here. So then it will flush and keep everything into a segment, basically into the disk. But if the space is empty, then it will see if the T10 is achieved. We are at T10, then it will again whatever the data the RAM would have, it will sync it to the particular segment. Okay, this is how segments work. Now when the segment is flushed into the disk, another operation is run in background, another check is run in background. Lucene also checks, can I merge these two, or can I merge these two? Why do I want to merge it? I want to merge it because I want to save space. If let's say it has X number of words, let's say Sarthak word, it has segment 1 has 10 times, and this has Sarthak word 20 times. Okay, in 20 documents, and this one has 10 documents, and like this we have 100 words here, we have 100 words here. Okay, so now we are keeping these 100 words in a separate place, these 100 words in a separate place. So why do we want to do that? Can I merge it so that all these Sarthak and the other 100 are kept here, so that I can increment this count to 30. So this operation is done, and this is how it creates a new segment out of it, so that it can save space, it can save fetching time as well for that particular index. Now this happens asynchronously, and it is not guaranteed. We cannot guarantee that it will happen at the real time only, everything. But if we want, we can force force flush this so that new segment is created. Now this is where the merge sort comes in. So if you see, this is nothing else but a merge sort. So we have these three, it gets merged into here. We have these three, it get merged into here, and then we get merged into here. So just the twist is that Apache Lucene does not know how long the list is, how much is the data. It can have infinite data, and it has to merge everything through merge sort for that infinite data. Okay, so now let's look at this segment. Let's say that if segment 1 is created, so can I edit more things? So if 1 is created, why am I creating segment 2? Why can't I put it in segment 1? So that would actually save creating a new segment. This is where a very fundamental rule comes in. Lucene never deletes any segment or alters anything. A segment is immutable. Once it has been flushed to a disk, it can never change. Even if you want to delete it, it will just keep a flag of delete. Delete equals to true, which will filter out and not include results for this segment. But it is immutable. Once this has been created, it will never delete. So this is why we are creating new segment every time, and that's why we need merge. We need to merge each and everything. Okay, so but what exactly is this segment and how the data actually is being stored? Because we saw that this is the entire workflow. We send the data, which are documents, to an index. Index stores it inside of segment. But it is still not clear how does actually it get stored and why it is so fast. How is it able to get us things in a corpus of so many records and documents? So this is where segment internals comes in. Okay, so let's we'll walk it through. Okay, we have three documents: document 1, document 2, and document 3. Now currently, just for the explanation and the sake of simplicity, I have kept the documents very simple. It just have a sentence. First one is the sun is brightest during the day, then bright is moon at night, and third one has sun and moon gives us light. Okay, so this happens inside every segment. Okay, whatever document it has, it first creates a stop word list. Okay, so what is stop word list? It removes the words which are redundant, because if let's say someone searches the keyword or is keyword, then it will fetch all of these documents. Now we don't want that. This is what the algorithm I was talking about. It filters it. It filters and give us only high quality results. So this is one of the features that it has. It creates a stop word list and removes a lot of things. Okay, so it will filter out all the things. So what we have left is some brightest during day. Okay, bright, moon, a night, sun, moon gives light. Okay, these are all the things, these are all the actual information which get filtered at this point. Now the rest of the information will go, and the rest of the information will go and stored as an inverted index. What is inverted index? Okay, so let's go down and first understand what is inverted index. So it is a data structure that is used by Lucene to index everything. Okay, we know that, we are looking into that. It has very fast lookups. Okay, but what exactly it is? So let's say that we have document, we have these words. Okay, so what it will create it for every word, it will create a mapping of doc. So how the actual index would work is doc 1 has cat and dog. This would be the mapping. Doc 2 has dog and horse. Doc 3 has elephant and cat. But now we are inverting it. So that's why cat has 1, 3, which is dog 1. Dog 3 has cat. Okay, dog 1, 2, it should be 1, 2. So this and this. Horse only 2, because it is in the only dog 2, and elephant on only dog 3, which is here. Okay, so this is the data structure, which is how everything is kept inside of a particular segment. Okay, this is the actual representation of how it is saved in the disk storage. Okay, so as we were seeing that we have sun brightest during day, bright moon night, sun moon gives light. Okay, now it goes to inverted index, and this is how it becomes. This is the ordinal, which is basically an incremental number of terms ordinal, and then we have all the terms that we saw. Okay, sun bright during day, moon night give light. What it will do is, whatever the duplicate it has, it just removes it and increments the document list. So d1 d3 d1 d2 d1 d1 document 2 document 3 night is only there in document 2, give is only there in document 3, light is only there in document 3. So this is called as terms dictionary for a particular segment. These are just the terminologies. You don't necessarily have to remember, but it's good to know. And then this is called as posting list. Now whenever the call comes inside, the call goes inside of the index, it searches for the segment. Okay, so we were looking at this, right? Now some query was made to the index. Now if the call is came to index, it will first see which index it needs to fetch that, and then it will search for a particular segment. Once it has been done, then it will come here, and then it will search inside of this inverted index, and then it will see that let's say the word is sun, then it is stored in document d1 and d3, so it will return this and this document back, and then the response will go back to the client. So this is the internal working of how Apache Lucene actually works, and this is the basic principle for Elasticsearch as well. Okay, so we talked about it, right? Elasticsearch is also an implementation of Apache Lucene in a distributed manner. Now, what I have told you is that let's say that we have these many horizontal instances. Now, each one would be running Apache instance of Apache Lucene here, and Elasticsearch will be managing this entire cluster. Okay, and this entire cluster will be managed by Elasticsearch, but internally it will all be Apache Lucene, which we just talked about. So this is this is how the search engine works inside of an app. So if we go back and look at Swiggy, for example, we have let's say this is some food. This is biryani, and it is true for these many restaurants. This is R1 and R3. So what will happen when someone searches for biryani here? The call will come, go to index, go to segment, go to inverted tree. It will check that it is being served by restaurant 1 and restaurant 3. Now it will give back, and then we will have some business logic. We will have some business logic here, which will if I give the restaurant 1 and restaurant 3, then it will return me the actual clickable restaurant things. So that is the exact implementation of search engine. So once you understand this, you understand that implementing a search engine is very easy. You don't have to do much about it. You just have to use Apache Lucene. If you want, you can optimize it and create a custom search engine as Google and Bing has done it. But in most of the cases, in most of the companies, it is not required. Now Twitter is also running direct version of Apache Lucene. Swiggy is using Elasticsearch, and Wikipedia was using earlier Apache Lucene directly. Now it has moved to using Apache Solr, which is just a managed version. Okay, so I really hope you liked this video and you understood how Elasticsearch internally works and what is the base principle of Elasticsearch.